Hello everyone. My name is Sayed Mahdi Sahafi Najafi Najadi. My edX username is Sayed Mahdi J2D0A3E, and my GitHub username is Sayed Mahdi Najafi. This presentation was recorded in August 2026. My topic is Device Code Phishing, with a focus on a Microsoft 365 campaign that occurred in March 2026. I chose this topic because I am interested in identity, security, and authentication. I also found this incident particularly interesting because it demonstrates how attackers can abuse a legitimate authentication mechanism rather than simply stealing a password. This topic relates directly to several concepts covered in CS50's Introduction to Cybersecurity, including authentication, multi-factor authentication, phishing, social engineering, OAuth, tokens, identity and access management, and incident response. To understand this attack, we first need to understand device code authentication. Device code flow is a legitimate OAuth authentication mechanism, standardized in RFC 8628. It was designed for devices or applications where entering credentials directly is difficult, such as devices with limited input capabilities. The normal process is straightforward. The device requests a device code from the authorization server. The user is then instructed to open a browser, enter the code, and authenticate. The user may be required to provide a password and complete multi-factor authentication. After successful authentication and authorization, the device can obtain tokens and use them to access the resources that it has been authorized to access. So, device code flow itself is not malicious. The problem occurs when an attacker controls the device code request and tricks a legitimate user into authorizing it. Now we can look at the attack itself. The attack begins with a phishing message designed to look like a legitimate business request. The victim follows the link and reaches an attacker-controlled landing page. Instead of simply asking the victim to enter a password into a fake login form, the attacker generates a real device code. The victim is then instructed to visit the legitimate Microsoft authentication page and enter that code. The victim may enter their password and complete MFA. From the victim's perspective, everything can appear normal because the authentication page is actually legitimate. However, the device code was generated for a session controlled by the attacker. Therefore, when the victim successfully authenticates, the attacker can receive the resulting authorization and tokens. This is what makes the technique particularly effective. Traditional phishing usually attempts to steal credentials. For example, an attacker may create a fake login page and ask a victim to enter a username, password, and possibly an MFA code. Device code phishing is different. The attacker does not necessarily need to steal the password directly. Instead, the attacker makes the victim perform a legitimate authentication action for an attacker-controlled authentication request. This means the victim can successfully complete MFA while still giving the attacker access. The important distinction is between authentication and authorization. Authentication answers the question, "Who are you?" Authorization answers the question, "What is this authenticated session allowed to access?" In this attack, the authentication can be completely successful while the authorization is being abused. Now let's look at the real-world incident. In March 2026, Huntress investigated a large-scale Microsoft 365 device code phishing campaign. The investigation identified activity affecting hundreds of organizations across multiple countries. The attackers used phishing and social engineering to convince victims to complete device code authentication. The campaign is particularly significant because it demonstrates how legitimate cloud authentication infrastructure can be used as part of an attack. The attacker does not necessarily need to deploy malware on the victim's computer. Instead, the attacker can abuse the victim's identity and the authorization mechanisms of the cloud service. This changes the security model. The endpoint may appear clean. The Microsoft login page may be legitimate, and MFA may succeed. Nevertheless, the attacker can obtain an authenticated session. After the victim completes authentication, the next important part of the attack is token acquisition. OAuth access tokens represent authorization to access specific resources. The attacker can use the resulting token to make requests as the compromised identity, depending on the permissions granted to that identity. Refresh tokens can also be particularly valuable because they can allow continued access without requiring the attacker to repeat the original authentication process. This is why token security is increasingly important. A modern attacker does not necessarily need to steal a password. A valid token can sometimes be just as valuable because it represents an already authenticated and authorized session. This also explains why simply changing a password may not always be sufficient to immediately eliminate every active session. Security teams must consider tokens, sessions, and their revocation as part of incident response. This brings us to the central question. Why was MFA not enough? The answer is that MFA was not necessarily broken. In fact, the victim may have successfully completed every authentication step. The problem was that the victim was authenticating an attacker-controlled request. So we can describe the process like this. The password was correct. MFA was successful. Microsoft Authentication was successful. But the resulting authorization was associated with the attacker's session. This is why it is important not to treat all MFA methods as equally resistant to phishing. MFA significantly improves security compared with passwords alone. But organizations should also consider phishing-resistant authentication, device trust, conditional access, and the context of each authentication request. The goal is not simply to verify the user. The goal is to ensure that the user is authenticating the correct application, device, and session. This incident also illustrates the difference between network security and identity security. A firewall can restrict network traffic, limit access to services, and protect internal systems. However, a firewall may not be able to determine that a legitimate employee has been manipulated into authorizing an attacker's cloud session. The connection to Microsoft's infrastructure can be completely legitimate. The user can be legitimate. The authentication can be legitimate. The MFA can be legitimate. The attack happens at the identity and authorization layer. Therefore, organizations should not rely exclusively on network perimeter controls. Firewalls remain important, but modern security also requires strong identity controls, conditional access, device security, authentication monitoring, and token protection. In other words, identity has become another security perimeter. There are several practical ways organizations can reduce the risk of device code phishing. First, device code flow should be blocked when it is not required. If an organization genuinely needs it, access should be restricted using appropriate conditional access policies. Second, organizations should use phishing-resistant authentication where possible, including FIDO2 security keys or passkeys. Third, organizations should monitor authentication logs for unusual device code activity, unfamiliar devices, abnormal locations, and suspicious token behavior. Fourth, email and URL protection can help identify the phishing messages that begin the attack. Fifth, organizations should have an incident response process for compromised identities. This should include investigating active sessions, revoking appropriate tokens, and requiring re-authentication when necessary. Finally, user awareness remains important. Employees should understand that even a legitimate Microsoft login page can be part of a phishing attack if the authentication request itself was initiated by an attacker. The strongest defense is therefore layered defense, rather than reliance on a single security control. To conclude, this incident demonstrates an important change in modern cybersecurity. Attackers do not always need to exploit a software vulnerability or steal a password. They can abuse legitimate technologies and legitimate authentication mechanisms. Device code flow is a useful technology, but it can become a powerful phishing tool when attackers control the authentication request. The most important lesson is that MFA and authentication are not the same as complete identity security. Organizations must also protect authorization, devices, tokens, sessions, and cloud applications. Network security remains important, but identity must also be treated as a security perimeter. By blocking unnecessary authentication flows, using conditional access, deploying phishing-resistant authentication, monitoring identity activity, and responding quickly to compromised sessions and tokens, organizations can significantly reduce the risk and impact of attacks like this. Thank you for watching.